we'll be solving the task actually, the tasks of today. There are some sorts of application, but we are going to see different techniques also. We know what is the concept of the memory allocation, but we'll use dedicated methods for that, functions and procedures. And beside of that, we'll talk about the duplicated block allocation, blocks of memories allocation. The same using functions and procedures. And beside of that, not a simple block, but an n number of blocks for n, let's say, spaces to be allocated for dedicated variables, maybe lists, pointers, or arrays. We will see that. So just let's dig in. I'm going to start with task number 1, which is talking about creating functions, different functions, to allocate different memory spaces for different data types. Here in this example, we are required to create 3 different functions. The first one is to allocate a memory space for a double, the second for an int, the third for a char, specifically and clearly. Let's just dig in and we'll explain step by step. I'm going to start with explaining the topic. Here we are in a new program. I'm starting my body. Without creating a method, I'm going to just, first of all, let's just dig in from the beginning as it is requested by the question to make it actually more clear. I'm going to create a function that has to return a double. I'm going to say actually set double. It's a method that sets a double space, and I'm going to give it, is the prototype, simple like that. And I'm going to call it here inside the main. So the same set double here, simple like that. And after the definition here, double, and it has a scope. So here we start, and here we do termination. Yeah. What would this actually method do, or this function do, is just to, I'm going to just declare simple double. Come on, double. It is to be set here as. I'm going to declare. Let me just make intentionally some errors. Just D here, and I'm going to say that this double would be actually allocated as a new double space. Simple like that. Finished. My task is being finished for setting up actually a space for a double, no more, no less. Yet, just to make the thing actually readable when I execute, let me check actually if this representation is correct or not. First of all, then after I'll tell the context of the output, if it to be readable, to be understandable, what has been done or not. First of all, the errors I have here, it's talking about allocating a new for a simple value, for a simple position, not an array and not a pointer, neither this nor that, which is not actually permitted behavior to be happening, while there is syntactically there is no error. Syntactically there is no error, if I dare to say that. Yet to insist that we're allocating a space for a standalone variable, it is for no use. Thus, I have to change this variable into a multitude of values, or just simply just state that it is a pointer here. So to avoid such an issue here, just state that the variable we are manipulating is a sort of a pointer to a position. Thus, we need a space for it. This is a simple pointer to a position. So to that position, we need a space, and here it is. No output, no errors. No output, no errors. No, there is an output here actually, but it's empty. And I have something here. Main and function double, main warning return statement in something. Yeah, exactly. I have to have the return since it's a function. So I'm going to say here, simple return, and be simple return. Okay, just let me execute again. 0.0 without any issue. So here actually no output, absolutely, absolutely, because we are not saying any CR or something like that. So actually to avoid that and to make the thing readable for us, we declared that and we stated that earlier in an early age. I'm gonna just ask the system to say if he allocated this space. He just said that. So I'm gonna say if it has been allocated, I'm gonna say cout, yeah, double space has been allocated. Let's say allocated. That's great. Less than an end of line. Simple. Else, come on. Else, cout, space not set. Less than an end of line. Great. So if it has been done, this affectation here means it has been there has been a space for type double or a type double has been allocated. So this message has to be displayed. Otherwise, means not allocated means this message should be displayed. Let's just execute. Double space has been allocated. Simple. Simply like that. As simple as that. So we have an output which is set inside the method, which is a function, because we have a return and we have a data type, not a void. This method here, this function, is being called in the main, and this is the key for making this message be displayed. If I change it to a command, and I execute, so it would not give me any output, but no errors also, because we have no call. Okay, let me call it again. And this is the prototype because we are just stating that we are going to use such method later on. Here it is the use, and this is the definition. So to finalize, as we did for the set double, let's set for the second data type, which is the int, and then after the char. So I'm going to create a new prototype. At int, I'm going to say prototype done. I'm going to call this method here inside the main, set int. Okay, and I'm going to bring the definition here at the end here. I'm going to say an int, so I have to return an int. I'm going to say set. It's the same actually as the prototype. It has to be the same here. As we define the prototype here, it has to be here. Okay, set int. The scope. In the scope, I'm going to just refer to declare an int pointer, straightforward. PI, I'm going to say PI here. PI. And I'm gonna immediately straightforward, so we know the secret. So I'm gonna just call the test of affectation. This PI equals new int. If yes, so cout, simple cout here. Int space has been allocated. Yes, less than an end of line. With else in the controversy case, that will be actually space not allocated. Okay, double quotation and an end of line also the same way. Here I return 0 or something like that. Int. Here y is 0.0 because we need to return a double. Here y is just simply 0 here because we need to return an int. I'll keep it 0.0 and we'll see what this system will do, what this compiler will do. Okay, the call has been done already, so we finished. Let me check. Int space has been allocated. It did not declare anything here actually for us, but it has to give any warning, something like that, but it did not do. This is a compiler secret, no more, no less. So take it off. It is not something to be utilized within int. Great. So the second function has been created. I'm going to create the third function, which is for chars. I'm going to say char, but char, yes, it's a prototype here, just on terminator. Let me call it. Okay, I call set char. No, char. Set char. Yes, that's good. Let's pass to the definition. Okay, char. Set char. It has a scope and it has a termination. Okay, in between here, I'm gonna define my pointer to a char, and then after I'm gonna just call my test if when I say PC, make it different. PC here. If PC equals new char, so see out char space has been allocated and end of line. Okay, good. Else in the controversial case, the cout here would print us something like space not allocated. Okay, exclamation mark, less than, and end of line. Great. Here I'm going to just print return also. But return what? Single quotation, let's say A. Something like that. Even I can return 0 here in between two two single quotations, something like that. It is valid. Let me check. Call and prototype are there. So char space has been allocated. It works very fine without any issue. I'm going to change the single quotation to double quotation. Remember at the beginning of the class today morning, we said that this is valid as a character and this is valid as, yes, a string. The number is usually valid to be a character, but the vice versa, character cannot be validated as an int. Let me just execute with double quotation here. Not accepted as per the compiler rule. It is the theory also. No, it is for a string here. It's not for a char. So if I change this thing to a string, and let me see if it reads the string only, this compiler, it will not give an error here. It will give something different here. Let me char, because he's saying, let me change all to string, just for purpose of demonstration only. Okay, char space has been allocated. It works very fine. So if I change it to string, double quotation goes. Let me change it to back to single quotation here. Would it be accepted? No. So we have to respect the annotation, no more, no less. Let me return it back to char, and problem has been solved. Char and one. Execute. Everything is being solved. So this way we are able to collaborate the use of the three methods to allocate three different spaces. Those are not methods, those are functions. For a double, for an int, and for a char. We are calling them here in the main. We have only calls, and here we have the definitions. Number 1, number 2, and number 3. This way we did it. That's number 2. We are going to solve the same issue, but using procedures. Procedures only. I will avoid to make copy paste. I'll just try to solve the thing actually manually to make you understand, no more or less. But it is a sort of cancel here. I'm going to just use the same compiler. Great. Okay, in here in this scenario, I'm going to use a procedure that does the task of allocating space, which is a double and then after an int and then after a char. To respect so, how to do so. Immediately I'm going to start by giving the name here set. I'm going to say double When I say P means procedure, just user defined. It's a procedure, semicolon. Since it's a procedure, there is no doubt the data type has to be a void. Simple. I'm going to call this method. I'm going to call this method inside the main. This is it. Done. I'm going to define the behavior of this method. So this is the name. This is the scope. And the data type in return. Void. Great. And here in the process, we're going to allocate the space we need. So first of all, we need a double. We need a double to, let's say, declare a PD pointer for a double. And now we'll do the test. Actually, if I'm going to change it a little bit, I'm going to say if not allocated, how? PD equal, let's say, new double, out, space not allocated, less than an end of line, else the controversial case, which has been allocated. So I'm going to see out simple message to say double space has been allocated, exclamation mark, less than, end of line. We did it. I changed the order on it, but here is if it's not allocated, so not allocated. Otherwise, allocated. Let me execute. Double space has been allocated. It works very fine. So perfect. The same way I'm going to do, actually, it's a procedure. There is no return. There is no return here. There is no return. And there is no data type. The data type is void only. The same way I'm going to do it for actually an int. So int, it's a procedure prototype, semicolon. Set int, the prototype call has been done. And the definition. Int, set int, scope, resolution operator, scope only, scope here. Here I'm going to declare an int pointer, pi, let's say, and I'll have to immediately the test, no worries. So here I'm going to make it a little bit different. Also, if not pi equals the new int, out, not allocated, and end of line. Else, the controversial case, which is yes, it has been allocated. I'm going to say here int space has been allocated, exclamation mark, and end of line also. Any return? No, we do not need any return. If I test, will I have a result? I have to, because we already did the call. We have an error. We have an output. In space has been allocated, that's absolutely, but also we have a warning. No return statement in the main, he's saying. Actually, why? Because we define this one as a function. It's not a procedure. Now it is a procedure, and here also we have to declare it as a procedure. Void. 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 Execute. That's it. Double space has been allocated. Int space has been allocated. No warnings, nothing. They're procedures only. The third procedure, again, it's a void only. I'm going to set char. It is for characters only, semicolon. Let's call it. Do I have to write void? No, no. No writing of voids here because we are calling, we are making the call. We are not making the definition of the prototype declaration. Only call. Definition. So the same declaration prototype, a char, and here's the scope. In between here, I'm going to say char pointer PC. Now, my test, if not has been, let's say, allocated, means PC equal new char. So in this case here, cout space not allocated and an end of line, an end of line. Yes, exactly. This is for the second question. It is for the procedures only. It is for the procedures only. This is the task here we are solving. Now I'm just solving this space allocation for the char. For the char. Now this is the procedure I'm solving now for the char. Else, which is yes has been allocated. See out less than. I'm going to say char space has been, let's say, allocate exclamation mark. And then less than an end of line also. All we have it. And this is the definition. This is a procedure. So no need for return. Execute. That's it. Double space has been allocated. Int space has been allocated. Char space has been allocated. Using what? Using procedures. Straightforward. Let's pass task number 3. Okay, again, we are required to use the functions only. Function to allocate space for a double, for an int, and for a char. But here we need a block of, clearly, we are specifying a block of memory. It has to be clearly utilized. So the difference in between simple allocation here of a space and the block allocation is that we are going to give an initial value to be set within the space allocated. No more, no less. We allocate the space and we put a value in it. Then after it is being said, a block of memory is being allocated for the given data type, Let's do that. So I'm going to create, I'm going to use a different, let's say, compiler. Okay. Here, and he said the function, so I'm going to use the same with straightforward. I'm going to use actually I may do copy paste and make modifications, so but I'll do that manually step by step in order to make you understand. So step by step we proceed. I'm going to just declare let's say double. Set block double prototype. Set block double. I'm giving it the name. I'm going to just call it in the main. set block double. Okay, the call has been terminated. And now the definition. The same data type, so double set block double. Okay, and the scope here it is. Great. In between here, simple, simple. We'll just declare, let's say double. Double. I want to say D, oh, let's say space forward, it's a pointer to double. So PD. And then after here, I'm going to just pass to my test while I'm doing the allocation at the same time. So the allocation would be like so, PD equals new double. Done. The allocation has been done. And this affectation here is a secret of the allocation, or the, let's say, the method later on, the memory space allocation. Simple like that. So see out here a message just to clarify that. Double space has been allocated. Else the second or the controversial case, else see out no space in memory allocated. No, here I'm gonna just say it's a typo. No space in memory allocated. Is being allocated. Great. Let me test. We have the method, the call, and the definition. I have errors, and let me check what are those errors here. Great. Simply, he's saying was not declared. So double is not declared. What is that? It is PD was not declared in the scope. PD 7U. Okay, PD 7U. Ah, yes, PD is in double. Also, this one is in small. Sorry, it's semicolon here and semicolon here. Let me execute again. Yes. Still, I have see out no space is saying. See out. What is this? Yes, here. The function is see out only. Yes, this is execute again. Okay, double space has been allocated, but still I have actually warnings. No return statement in function. Simple. Return double 0.0, something like that, semicolon. Okay. Double space has been allocated. This is the message. We did it for this context here, but it's not allocated in a block. It is simply allocated here in memory space without a block. To do so, this block of if and this block of else, I'm going to put them into two curly braces here. Here it is. And the same thing I want to do it for this else. So the scope of this else here. Terminated. Okay, no space. Let me execute. The same scenario here. Double space has been allocated. No, nothing new. I need to make no here double space has been allocated. I need to make actually a specific size. In here, I'm going to say PD, the pointer we declared already, would receive will receive equals, let's say, 3.87, whatever, any double number from double. Now we have the initialization. Let's still check if this allocation has been happened or not. Execute. There's a problem here. So you convert double to double star. Yes, so here we cannot convert double to double star here. This one is a star, so double star to double star. Double space has been allocated. Perfectly fine. Double space has been allocated. Okay, now we allocated a block of space type double to this variable, which is pointed to double. The same for an int. So int, I'm going to say set int. Let's say set block int. Same way. Set double int. Here, and the call, I'm going to move. Is the call? Yes, absolutely. What is that? I missed something here. The prototype has been terminated. Yes. And let's define it. Let's define it. I'm going to just copy here and move the last. Curly braces to indicate the start and the end. And the definition, I'm going to declare an int, which is a simple pointer, I. Okay, there's no curly braces. Okay, my if condition, my if statement, if there's no dollar here actually, if my pi equals new int cout int space has been allocated. Okay, then fine. Else the controversy means pi did not get the new int here. It's new here. Simple cout space, nothing in capital, not located. Now offline and offline. واللي هي semicolon. Okay, let me test pi. They are is user defined only. PD user defined, and that's the PC. It is the last one. Let me just pass to you the last one, which is char. But I did not finish here. What is it? Here in the int function, you have to allocate a block of int. It's not an int. A block of an int, we just declare this pointer as an array, which is the case, which is an array already, an array. I'm not gonna bother here because we will see something later on for the n blocks. I'm gonna just change this int into, even here I will not touch immediately. I'm gonna just give it a scope here, and here terminates. Yes, here it is, and start here, close here. Okay, great. So in addition to this phrase here, before that, I'm going to say in this affectation here, I'm going to give the I a value. It's an int. Let's say 1. Semicolon. It's an int. Let me just test that. And the I here actually without a star, I'm writing it. Let's check the errors. Yes, set double int. What is this set double int? 12. It's not set double, so the block. Yes, exactly. Set block int alternative. He knew that. On the same name here, I'm going to copy it. Okay, that's good. That's good. Let me execute it again. Still an error. Pi new int does not name a type. Did you mean? Set block int. Line 28. New int. It's a small only. Let's execute now. Yes, the main has been an issue. And 29 here is the one. So here actually it's the content of the PI. So star, just simple star here, and execute. Execute. Double space has been allocated. Int space has been allocated. And the space has been allocated. Yes, okay, it works very fine. So just the third one only. But here, the block, we need the block. The same way as we did here. Just we need the block now. What is the valid affectation? The valid affectation here. So we'll make the initialization here. It is done already. We'll not make it in the opposite. We can do it here. It will not give an error, but it's not the request. The request is to allocate the block for an int. And this is the place we are allocated the space, and we are given the value here. So here the block has been, let's say, reserved. Just to avoid the issue here, just let me give an end of line for each here, and the same thing here, an end of line. Okay, I'm gonna just pass to the last method here, which is the char. Set char. Let's say set the block char. Okay, it's a method, it's a function now. Set the block of char. This is the prototype. Just call it here. Great. Let me pass the definition now. Let me just copy paste to avoid any error. No semicolon, the scope. Here it is. The scope has been done. What would be the process? Char, I'm gonna say it's a pointer to char, something like that. Okay, and then after my test immediately straightforward. So if let me just respect the same order. So PC equals new char. Jump. Thus, I'm gonna just make the simple message here. Cout less than. I'm gonna say our space has been allocated, and end of line for this one. Else, my else here would be playing the role here of just stating the message that the space is not being allocated. So space not allocated. Simple exclamation mark, double quotation, and end of line. Yes, if I execute, it would run, but it's not the purpose here because we need to allocate the space as a block. First of all, I have errors. Let me check what are the errors. Start with function set block int warning, no return statement. Yeah, okay. No returns. Those are warnings only. They are not errors. Okay. Char space has been allocated, int space has been allocated, and double space has been allocated. Very good. So let me come back to my. Let me finish up here. It needs to be a block, so I'm going to give curly braces as a scope, and I'm going to terminate it here. So in here, I'm going to give a value for PC equals the single quotation A. Semicolon. Done. Without star, I'm writing. It will give me an error, but okay, I'm done. So let me check. Yes, A cannot be given here. Char to char star cannot be happening. So simple here. It's a pointer. So the content of execute. Yeah. So I have warnings. Yes. Return, and the output is working very fine. Let me just fix this context of warnings. Char. So there have to be a return. When I say here single, something like that. It's an int, so there has to be a return also here. Return 0. It's a double. There is an return. So it works very fine. Let me execute now. Okay, now warnings and the three messages they are being displayed. The int has been, let's say, allocated, and the char has been allocated, and also the double has been allocated. So perfectly working. This is a block of char allocated. This is a block of an int has been allocated. This is a block of let's say double has been allocated. The call and the prototypes here. They are. So this way, we are sure that it is working perfectly. Let's pass to the last task, which is, okay, let me pass to the last task. The same scenario, we need functions to allocate a block of memory, let's say of size n for a double, for an int, and for a char. The point is here that we are not going to allocate simple one double, one int, one char. We need a block of n doubles, n ints, n chars. Simple then simple. I can do copy paste, but I'm not going to do it. I'm going to just start a new compiler. Okay. Method, first one, since he's saying functions, the question said functions. So let me use that. So I'm going to say double first of all to set double. It's a prototype. I'm going to call this set double. I'm going to change the name. Set n block double. Let's use the same. Set n double block. I'm calling it here, semicolon. And let's have the definition here. So double, set n double. The scope starts here and terminates here. Okay, that's good. Double, so simple double. I'm going to say pointer to a PD. And if, let's say, PD equals new double, so خلاص. Immediately I'm going to say cout. End of line. Else, cout, let's say here space in general, whatever, not allocated. Okay, and end of line also here to avoid any confusion. To be a block, simple. Scope, and I close the scope here. Before of that, let's give a value. So for the PD, no, it's a PD capital. I have to respect. Yes, here PD. I'm going to give, for example, here 1.5, something like that. Okay, and this is simple block allocation. If I execute, whatever, what is that? He's saying 1.5. There is an issue here. Double set and block cannot convert double to double star. Yeah, that's good. Yeah, because here it's a pointer, just the name of the pointer. We need the content to be initialized. The pointer here. Let me execute again. Okay, second error, but it's double set. Invalid operand. Type constant char. Where it is? 1548. This is the one. Yes, here. Double less than. Less than. Okay, execute. Okay, we have a warning now. No return statement in function return non-void. Okay, here I have to have a return. So here it is. Return 0.0 semicolon. Execute. Okay, double space has been allocated. That's wonderful. We are now allocated. The question did not ask us to allocate one space. This one I do not need it for now. I'm going to allocate as per the question n spaces. Let's say 10, 15, 20, 100. We need n as per the need. What is that? I'm going to allocate still double only, but for how many? Any doubles. N doubles. This n here I have to initialize. So this way I may say 10, for example. I may say 100. I may say 5. I may say 70. I may any. It depends on the size I need. So let's say 10 and stop there. I'm going to say 10 doubles, and I do not need this one. No more. There is no more needed. Command execute. Double space has been allocated for, let's say 10. Let's say here 10 double spaces have been in plural. They have been allocated. Execute. That's it. 10 double spaces have been allocated. So it works very fine. So I do not need this one. I'm going to take it off. Leave it like that as a command for reference only. The same thing, I'm going to just declare an int. This is an int that unblock int. I'm going to call it here inside the main, semicolon. And then after I'm going to define it here. Int scope. Okay. In the scope here, I'm going to say int pi, semicolon, if my pi equal new int. Okay, خلاص. I have a scope immediately. Inside the scope, I'm going to do my task, which is out less than 10 spaces, 10 int spaces have been allocated. What are those 10 spaces here? Less than and the line. Here they are. Here, 10 or 50 or 100, whatever. They are more than one. We can say 2, we can say 3, whatever. Else, out less than spaces, let's say spaces have not been allocated. Quotation less than end of line. Simple. And here let's say spaces also not allocated. Okay, that's good. Execute. Error. Warning. Return. Okay, here we need the return. That's true. I forgot that. Return, let's say 0. Execute. Okay, P to a new. We cannot give actually. What is that? Line 26. This is the one. If pi equal new and pi. Invalid from int start to int permissive. Did I miss something? Int, yeah, exactly, because it is a pointer. It has to be a pointer here. Yeah, here it is. 925. Execute. That's good. 10 double spaces have been allocated. 10 int spaces have been allocated. That's perfect. The same way, char. Let unblock char. I want to call this method here. And the main, so here it is. Paste it, that's good. And I want to define it. So here, char, scope, yes, in here. So char pointer PC, and if my PC equals new char size, let's say 10 or whatever the size we need. Okay, scope in here, see out, less than, and just spaces have been allocated, less than end of line, else, see out, let's say here, no space being allocated. And end of line. Wait, let me execute. I have a warning, yes, but it works very fine. The warning is because of the return only. Return, let's say, single character A. Okay, execute, and finally, yes, it works very fine. I'm gonna stop the record and give it to you just in a while.